Can't you just use this recent photo?
All right. Here you go.
Woohoo! Who's laughing now? Shut up!
Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you. And I came across this over at Science Alert. This should be entertaining. All right, so scientist proposes a new universal law of biology that may explain aging. Let's hope it involves alcohol. We can only hope. All right, so life appears to require at least some instability. That fact should be considered a biological universality, proposes University of Southern California molecular biologist John Tower. Now, biological laws are thought to be rare and describe patterns or organizing principles that appear to be generally ubiquitous. While they can be squishier than the absolutes of maths or physics, such rules in biology nevertheless help us better understand the complex processes that govern life. Again, I'm not a scientist, don't claim to be, but if there are any biologists out there that'd like to comment on this, please give us your input because we'd love to hear from you. Yeah, and then I'll leave the link to the main article as usual below the video so you can pop in and check out these embedded links if you like. Go for a bit of a deeper dive beyond the main article. Makes for a very interesting read, believe me. Now, most examples have found so far seem to concern themselves with the conservation of materials or energy, and therefore life's tendency towards stability. Now, for instance, Allen's rule, formulated in 1877, states warm-blooded animals in colder areas require stouter limbs with less surface area to conserve body heat. Now, whereas in warmer regions the opposite is true, but as with everything biological, there are some exceptions, including short-legged bush dogs found in Central and South America and the common frog. I wonder if that's... See, could somebody explain to me about bees? I heard somewhere once, is that a myth? You know, like bumblebees, you know, aerodynamically impossible for them to fly, but nobody told the bumblebee that, so it goes and does it anyway. Kind of fond of bumblebees. You know. Yeah, don't ruin a bumblebee's mojo by telling me should be aerodynamically impossible for you to fly, buddy. That'd be a bit mean. Another example of biological rules lies in repeating structures that obey mathematical power laws as they increase in size, such as the ever-expanding spiral of a nautilus shell. As in, there you go, nautilus shell. Interesting. Yes, these are widespread across many biological systems, and again, are strategies believed to conserve the use of energy and material. The way bees make hexagonal honeycomb is another clever example. Yeah, if you've got any more examples, please throw them down in the comments because we'd love to hear from you. I just love all science and I love sharing science stories. I'm a student of all sciences. I just love it. Now, similar structures, including logarithmic spirals, are thought to be the most economical way to grow the size of a structure without changing shape or destroying existing structure, explains Tower. Now, his concept, termed selectively advantageous instability, however, challenges this tendency towards the conservation of resources in biological systems. Now, it claims at least some volatility is a fundamental biological necessity. Despite such instability leading to the loss of resources, that's because there are other things to gain. Now, selectively advantageous instability increases the complexity of the system, and this increased complexity has potential benefits, Tower writes. These benefits include the power to change and therefore adapt, which occurs across all biological levels to the molecular to population. Yes, adapting to particular climates. I mean, imagine having a pair of twins being adopted out at birth, one going to live in the far north of Canada and one coming down to live here in Australia, separated at birth stuff. Interesting. I wonder how, if they swapped after they grew up, how they would adapt to the different climates. Interesting stuff. I love this sort of stuff. Again, don't know anything about it. I just love thinking a lot about it. I just find it fascinating, But adaptation is very important in life. I had an injury about 8 years ago, and I couldn't walk. I literally broke my hip. And for years and years, because of a poor health system and doctors that thought I had man flu, because none of them could sign a piece of paper to bloody go and give me an x-ray, get me an x-ray arranged, I ended up having a hip replacement, total hip replacement. I had to adapt to life with not being able to walk and being in great amount of pain 24 hours a day, to getting the hip replaced and then learning to walk again, because it was so long that I hadn't been on my feet. It wasn't like 6 months or something. It was 7 years. So you learn to adapt. And now, of course, it's been a year since the surgery. I'm now up and down and running around. But the thing is, it's like I'm adapting again, because I was on a mobility walker, so I never had any hands free. So now I'm walking around and I can pick things up and walk around, and it's weird, because now I can go to a chest of drawers and I can pull a drawer out and get my clothes out. Whereas before it was difficult because I had this giant metal thing on wheels, sex god with his love chariot, my ass. And I couldn't, it was that big. It was because I'm not exactly a small unit, it was a bariatric one, and I had to bloody basically lean over this thing to get to a drawer to pull it out, which then you couldn't do it because the drawer I was looking for was right in front of the walker. So I had to adapt. I worked my way around it, and I did it. Now I'm adapting again to doing things that able-bodied people do every day of the week. But adaptation is very important. And as they say here, power to change and therefore adapt. Interesting. Now, even the simplest of cells contains proteases, and nucleases. Sorry, again, not a scientist. And regularly degrade and replace their proteins and RNAs, indicating that selectively advantageous instability is essential for life, Tower says. Now, the requirement of instability inevitably leads to a loss of energy and resources, and the accumulation of genetic mutations that may either be harmful or benign. Now, this is how we end up with biological aging, Tower speculates. Yet without instability and its downsides, life wouldn't be able to adapt and flourish through changing time and space, and climatic changes, and changes in diet, and changes in pretty much environment, everything. So we're all caught in a contradictory tug of war between a need for stability and instability, making compromises either way. Science has been fascinated lately with a concept such as chaos theory, critically Turing patterns, and cellular consciousness, says Tower. Alan Turing, what a legend. Bletchley Park, Second World War, Enigma, broke the Enigma codes the Nazis were using. Yeah, well, he and his team. Yeah, absolutely amazing man, Alan Turing. Excuse me. Absolutely amazing man, Alan Turing. Definitely check this embedded link out and go and have a little look about the man Alan Turing, Englishman, war hero. Very, very tragically, the way he was treated. Once he helped save Britain in the Second World War, he was basically discarded because of his sexual preferences, shall we say. Very, very sad. Research in the field suggests that, by the way, just about Turing, here's a little side note for you. At the age of 22 or something, when he was at Oxford, Cambridge, whatever major university was in Britain, age of 22, now this guy died in the early 1950s, right? So you imagine, 22 years of age, he literally created with one university paper computer science as a subject. When everyone looked at the paper, they said, well, that's cute. That's a novel idea. Very funny. That's where the basis of computer science formulated, shall we say. It came together as a subject, as a field of research and study, thanks to Alan Turing. Definitely check the guy out. He's a legend, one of my heroes. Research in the field suggests that selectively advantageous instability plays an important role in producing each of these phenomena. This research was published in Frontiers of Aging. Yeah, very, very interesting, that. We all get older. There's not much we can do about it, but you never, ever know. The way things are going in some of the videos I've done on research on, starfish and bloody little sea creatures and everything that seem to be immortal, it's absolutely fantastic. They just can revert back to their childlike state or something. Again, not a scientist. You're probably marine biologists are probably wetting themselves laughing when I talk about this stuff. But please, feel free to comment down below because we'd love to hear from you. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
my brain hurts!